going to do linear regression on Desmos. These numbers are big. These numbers are bigger than anything we're going to have you do on a test, but it's really good. It's a really good skill to be able to take something from paper and enter it into the computer. Like life skill, not just math skill. What we're going to be doing is we're going to be using Desmos in a way we've never used it before, and you are only going to do this with statistics. Only. This unit and next unit are the only times that you are not going to put an equation into Desmos first. What we're going to do is we're going to put a table into Desmos, and then we're going to have Desmos help us with the equation. Again, this unit and next unit, when you're given a set of data, what we're going to do is we're going to go to the little plus and add a table. If you were given an equation, you would never do this. You put in the equation and then get the table. But here we have to add the table because we don't have an equation for this. All we have is population data. So this is population data for a specific part of the video. They started taking, it says they started taking data in 1970. That's going to be our year 0. And you're going to put in the data. It's going to really help you to do this. So I know the numbers are big and unwieldy, but that's what happens when we're talking about populations of African animals. Put all of them in. I'm doing it too. This is when I think it's more helpful to have, like, I'm gonna probably walk over to my computer and use the little number keypad. It's annoying to have to poke these numbers. I think it's nicer to be able to type them, but that's up to you. Oops. It's actually pretty unusual for an animal population to grow in a linear way. Usually if we're talking about animal populations, we have a lot of cyclings. Or like if animals are reintroduced to an area, like happened in Yellowstone in 2010, we had wolves were reintroduced. The population starts small, it spikes, and then it kind of flattens out or kind of goes on a cycle. Okay. So that's why if we're going to use a line to model this, we're probably only going to use a small number of years. Okay, so I'm going to double check my data in a couple ways. I'm going to count the number of lines I have here and make sure they match. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8, 9, 10. Okay, this is when I get nervous. And I'm going to spot check a couple of the numbers. 6, 4, 5, 0, 1, 7, 5, 1, 4, 7. It's really important that these numbers are good here. Because we're going to end up with an equation of a line. And if one of your numbers is off, it's going to pull your line off too. Okay, so once you have your data in, we are going to move a little so that we can see it. So here we had year 0 and we had our Y value is 2,815. Beautiful giant hippos. Okay, we can't see that right now. Even if I pull this, I'm only going up to 16. So if you want to see it, and you don't have to be able to see your scatter plot. I like to be able to see it though. I'm going to change my Y-axis. And since my biggest Y is, let's see, 6,500, I'm just going to change that to 700. And that's just under your little wrench. I'm going to change that to 7,000. Sorry, I said 700, I meant 7,000. I don't know, read my mind. If only I could just give you my should be able to see all your dots. My beautiful purple hippo dots. The X is really, my X is just defaulted to that. You can just make that 0. The Y minimum, yes. And then go back up there and change that to like 20. Yeah. So you just want to change your Y numbers. Data on the table. Okay. So we'll make that 0 to 20. All right, so what I'm seeing issues with is just the scale. I didn't touch the x-axis scale. Your x-axis scale can be 0 to 20 there. I didn't touch that. I just changed the y to be up to 7,000. So the only number I changed was this biggest y number. I changed to 7,000 so I can see my scatter plot. It's not that big of a deal. As long as you have that data in, you're going to be able to get the equation of the line. Okay? You're fine. As long as you have your data in, you're going to be able to see the equation of the line. But it is nice to be able to see that.
We want to see the data over here. So we're going to go.
For some reason, yours is connecting the dots. We'll work with that. Oh, it's because I'll have to figure out what setting that is. So some of you have Desmos is connecting the dots for you, and I don't know why it's doing that. Oh, it's because if you click the bubble there, do you see how mine is dots and yours looks like a zigzag? My purple, like the purple Y there. You just have your Y's here. So you just do that to 20, and that's 0. There you go. Okay, go back to your bench. And change your axis to 0 to 20. So up here, if you have zigzags, it's because of this. Oh, come on, give me that. That's so annoying. All right, if you have zigzags here, it's because of this. When you press this, you can do points or like your lines are on. You just want to turn your lines off. All right, now we're going to do the linear regression. So that we don't have to make. That's just because of your scale. Yeah. That's what we were just working on that. It's okay. Just put your data in. We're going to get the line. So the way we get the line is this. We type into B. Now we type into our second line here. Y1 And then you have to use, it tells you about it tells you where it's looking there when you type y1. It says, I'm looking back up here and there are 10 things. That's what it is. Y1, and then you have to get this tilde guy. That's called a tilde. It's next to the little brackets. It's also on your keyboard. If you have a keyboard, yep, it's right above the little apostrophe. And then you're going to type in m x1 plus b. Y equals mx plus b should look familiar. And that's how you get the linear regression. Now, that gives us the slope and the y-intercept. That gives us the slope and the y-intercept, which is awesome. No. You just have to get the data in. Y1, you're just typing Y1. You type the little squiggle. Y1 squiggle and x1 plus b. We will give that to you on the test. Okay, we will give that to you on the test. And then it gives you 3 pieces of information that are interesting and useful. It gives you m, which is slope. It gives you b, which is your y-intercept, and it gives you r. It gives you the r value. So we don't have to estimate r values anymore. We've got it. You're going to ignore r squared. So you don't have, looking at this, seeing our line with those dots around it is lovely, but I usually don't even mess with this. I put my data in, I get my line, and go on with my life. Okay, so let's see. Our regression equation, what we just got is this. Y equals something x plus something. And it gave us 301.304. I'm just going to use 301. And 2336.58.
Awesome.
There's your linear regression equation. We could use that equation to estimate any of the years that we wanted to see what the hippo population would be in this particular part. The slope of 301. Let's talk about this for a second. We have 301. Our y was hippos. And our x was deers. I feel like maybe we don't have enough predators in this situation if we're going up by 300 hippos a year. So maybe it's a really big part. So we have an increase of 301 hippos for 1 year between 1970 and 1983. All right, let's go down to the R value. Let's skip down to E, the R value. So our R value here is 0.8879. What kind of correlation is that? Positive or negative? Right there, it's from right there. Oh, sorry, yeah, I jumped. So our R value is 0.8879. What kind of correlation? Positive or negative? Positive, strong or weak? Awesome. So let's just look at this for a second. So we started in 1970. That was a lot of years ago. Do you think the hippo population is actually going to grow like that in this part?
Yeah.
Maybe for a while. After a while, This model would probably not, like, we probably wouldn't have 20,000 hippos, as much as I might love it. They're huge. They take up a lot of space and they need water, right? And so at some point, that population is probably going to flatten out. This model is really good for right here. It might even be really good for 40 years. But at some point, that model is not going to hold. So it's good to keep that kind of in mind when we're looking at more real-world situations. At some point, and that's this F, at some point our model is that, like, our hippos are going to run out of space. Okay? Let's do this again. Put this data in. I would every time, and the OST does this for you, which is lovely, but I can't do it for you in the middle of a test. Every time you get to a new problem, you want to clear out everything. Oh, come on. Why is this? So every time you get to a new problem, clear out everything. And then remember, this statistics is the only time we're going to add a table. If we're working with functions, we're just going with the table that is created. All right, here we go. We have sunglasses and ice cream.
Okay, guys, I need you to start putting the new data in. Some of you are a little bit ahead, which is great. Get that list in. I'm going to walk around. I'm going to help you. It's tricky if you don't get the list in at all. I can help you with the scale. Let's do this that for you.
And ice cream on the same day. Graders actually has an ice cream named after Fiona. It's called Chunky Chunky. Me too.
Okay, so plus sign. With the plus sign. Oh, okay, so we are not, get rid of that. This plus sign, yes. Table, yes. So here's your X, here's your Y. Very tricky if you do not do this with us. There you go. Good, 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 good. Okay, here's your X's, here's your Y's. This is zero math involved. This is just putting the numbers in, okay? So make sure the 215 is paired up with the 4.
So we're zoomed out a lot right now. Well, I zoomed out even more than you did. But that's pretty linear, even at that crazy scale. We don't need the scale. You don't need to see the dots. All right? You don't need to see the dots. So if that part is freaking you out, don't let it freak you out. What I really want you to do is be able to do this regression line. So we're typing in y1 tilde m x1 plus b. And what we wanted from that are the m, the b, and the r. M, the b, and the r. Don't worry about the appropriate window for the data. Calculate their linear regression line. If you type, I don't know if you guys notice this, but it's really nice. When you type Y1, it makes the one little for you. You don't have to do that, which is nice. Okay, so the M I got is 29.65. And the B I got is negative this time. I'm not going to clear anything out, but before I do anything, I'm also going to write down that R value, 0.9491. Those are the three important pieces of information there. Your M, your V, and your R. Yeah, our data is just a tiny bit off. Might not match up for one. 1456, 365, 1285, 19, 406, 22, 522. Oh! 19, 412 instead of 406. All right. It will recalculate for me right now. Now do math?
Yes.
Okay. Let's see, 29.66 instead of 0.65. 148. No big deal. All right. So 29.66 for 148.92. You guys corrected my work back there? Cool. Interpret the slope. All right. Our slope is 29.66. And we're going up here both. So our Y was ice cream. And this is all dollars. Ice cream dollars. And our X is sunglasses, number of sunglasses.
Angelica, is it real quick?
So as we increase by $29.66 of ice cream, we're selling, for every increase in ice cream sales of $29.66, we're seeing an increase in sales of one pair of sunglasses. Ice cream going up means sunglasses are going up. Tends to. What does the 0.9493 mean? Good model? Yeah, strong positive. It's a good model. Our two stores could work together to predict their sales. Does buying sunglasses mean you're hungry for ice cream? Wait, let's do this one thing before we back up. Does buying sunglasses make you more hungry? Yeah. Why are both of them? Yeah, shopping makes me hungry too. But yeah, but why are they going up together? So, please. When it's hot outside, do you want to eat ice cream? Yeah. And do you need sunglasses? Yes.